Let's graph the solutions of this system of linear inequalities. And notice each of these is a linear inequality, so we do have a system. Where are the solutions? The solutions will lie in the intersection of these graphs. So I've already graphed the linear inequality 2y minus x is greater than or equal to 1. Here is its graph. Let's now concentrate on the second linear inequality, x plus y greater than or equal to negative 4. Remember how we begin. We begin with the equation x plus y is equal to negative 4. And by the way, if x is 0, can you see that y must be negative 4? And if y is 0, x must be negative 4. So I have some intercepts. I have 0, negative 4. And then I have negative 4, 0. And if you're working alone, go ahead and find a third point as a checkpoint. But I'll go ahead and draw my boundary line. I will draw it solid because of the greater than or equal to. All right, concentrate just on this line now. And I need to know whether I shade above this line or below this line. So we check a test point. I'll check 0, 0. If x is 0 and y is 0, is this a true or false statement? That is a true statement. 0 is greater than or equal to negative 4, so I will shade above the line, and I'm simply graphing the second inequality in the system. Now, thus far, can you see where the intersection is? Thus far, it's this region right here. But now, let's work on the third linear inequality. So, how do we graph that third linear inequality? We begin by graphing y is equal to 2. And where does that graph lie? Remember, that's a horizontal line with y-intercept of 2. I'm going to graph it as a solid line because it is less than or equal to. Now just concentrate on that line, and then do we shade below this line? This is where you should be concentrating, below or above. We want to shade all y values less than or equal to 2, so we do shade below. And you can check a test point if you'd like. Now be very careful. Remember, here, for just the first two, here's the region of inequality. Here's the region of intersection. So where in the world is the region of intersection for all three? It is this triangular. You may be able to see it better with colored pens. It is this triangular region. In this region lies all ordered pair solutions of this system.